Welcome everyone, my name is Albert Rapp, and in this video I want to show you how you can take multiple ggplots and arrange them so that you have a larger plot consisting out of multiple subplots. And here I've set up in the code, I've already set up what we need for this. So we have the tidyverse library. I've set the theme to theme light, but you can go with the default theme if you wish. It doesn't really matter. Our dataset today comes from the Parma Penguins dataset, from the package which has a dataset penguins, and with that I simply filtered out the missing values, and this way we get a dataset consisting out of 333 observations, and we have variables like species, island. We have a couple of measurements from the penguins like bill length, bill depth. What else do we have? Flipper length. We have the body mass. And then we have knowledge about the sex of the penguin, and the year I believe is probably when the measurement was taken. Let's check. Yeah, so noting the study year, so I assume that is the year when the measurement was taken. Nevertheless, it doesn't really matter. We just need a bit of data to create a couple of simple plots. I did this, so we have 2 point plots here and a box plot. Plot. Here I did nothing too fancy. I simply took 2 of the measurements and plotted them next to each other and colored the points by sex. And I did the same thing here for the second plot, just taking 2 different measurements. And with the box plots I took the body mass and created a box plot for each sex. Alright, so these are the sample plots we have. We want to work with, and with the patchwork package it's really easy to compose a picture that consists out of these sample plots. So let's load the library. So here's patchwork, and with patchwork it's really easy to compose plots. It's simply done by adding or dividing plots. So let's see what happens here if I add plots. You see that the 2 plots are simply put next to each other, and if I divide this plot further by the box plot, as I said, we can add or divide the plots for arrangement. So let's see what happens then when we divide now. Well, the division puts the plots not next to each other, but in this case it put it below the other 2 plots. So instead of putting the box plots next to the 2 point plots, it put them below the 2 plots. So you can see from the syntax in the first row, basically there should be the 2 point plots, and in the lower row there should be the box plots, and this is exactly what we see here. So it was super simple to compose this picture here. But even though it was really easy, we should be aware that there's a lot of superfluous stuff going on here. So here we have a sex legend, here we have one, and here we have another one. I mean, yeah, it's not really good to have superfluous stuff there. So it's like code duplication, no point of it, and there's no point in having that. So let's try to get rid of this. And with the patchwork package it's super simple. Let's save this in a variable so we can work with that variable and do not write everything onto one line. So let's have this variable and add to it another plot layer. So as you can see here from the patchwork package there come plot layers, and with this we can customize the layout. And what do we want? Well, the layout is supposed to collect the legends into one space, into one spot. So this is what guide plot layout does with when I set guides to collect. As you can see here now, the legends were collected for us, but intuitively for us these 2 legends are one and the same. They have the same information for us because, well, the colors are the same, and we see that one color refers to female and the other color refers to male. But for patchwork it's not exactly the same legend because, well, here we have box plot symbols, here we have point symbols. So this is why it couldn't mingle the legends into one, whereas with the two legends for both points plots, it understood it's the same legend, so I will make this one. Here we could, for simplicity, simply get rid of the box plot legend by changing our initial box plot, saying, okay, the filling does not need a guide, so let's set this to none and recompute everything here. And there you go. We got rid of the box plot legend, and still, since the colors are the same, it's we know what is happening there. All right, so let's stay with the legends. Let's try to move it. With ggplot, you would know that you simply take add another layer by simply saying theme and then legend position. No, not legend background. Legend position should be set to none. And for some reason, this didn't work. And the reason for this is that if we use this syntax here, like we did, simply adding another theme layer, technically it would be hard, at least that's my understanding of why this is happening. It would be hard to differentiate between adding a theme layer to just the last plot added, to the last ggplot added, or to the whole plot, to the plot as a whole. So with the plus, we basically added a theme saying the legend position should be set to none, but we know with the box plots we do not have any legend, so this is why nothing happened here. So instead of using the plus, we need to make sure that the syntax highlights the fact that we want to apply this theme layer to the whole plot, and in patchwork this is done by using this AND operator. And now I said none, this is why it's gone. I wanted to put it to the top, so let's change this. Still, if our previous stuff would have worked like we wanted it to, then still the previous legend should have been gone and not to the right. Now with the AND symbol, exactly what we want is happening. And by the same logic, we can apply stuff like a scale layer for different colors to the whole plot. So if we want to have, for instance, a different color scale, let's use scale brewer and I don't know, set it to dark 2. And this didn't work because I used color. Of course, I would need to use fill. And now this is doing exactly what you wanted to. And this is basically the syntax or the logic behind patchwork. Simply apply with an add. What I want to say is add another layer that you want to apply to the whole plot by adding it using an AND symbol. So this was kind of complicated to say for me, I don't know why, but I hope you got it now. And let's try to make our plot even nicer. So here we have basically spaced everything equally. So both rows have equal height and both columns have equal width. Let's try to change this, because with the plot layout functions we see that there are arguments widths and heights, and with this we can customize our plot even more. So let's do this in another code chunk. So first I want to customize the upper layer. I want to use different heights, or different widths. So let's use plot layout, and the widths should be set to, I don't know, 0.7 and 0.3. So the first plot would get 70% of the width, of the total width, and as we can see here, this is what's happening. And then we can add our or divide our box plot again. So this is how it looks now. And we want to have the box plots become a bit higher. So we want to change that too. Again, we can use the plot layout function by setting the guides to collect first, because, well, we again have these two legends, and then we want to set the heights to something that adds up to 1, let's say 0.4 and 0.6. And this way we have changed the layout. We could use the theming from before, so put the legend back to the top and change the fill scale. That worked nicely. And maybe we want to change the label here for this for the legend. So let's use add labs to it with an and again. Fill is, I don't know, what could we write? Let's just write sex with a capital letter. Now this worked, and now we can, if we want to add a title and a subtitle or caption to it, we could use a plot annotation layer. So let's add it to the whole plot again. Plot annotation. What do we want? I don't know, a title. Let's write, what a great plot. We need an and here. And as you can see now, the what a great plot is added to this. Out of interest, what would happen if we would put it into the labs function? To title, say, what a nice plot. Would this yield the same picture? Obviously not. The logic here, I think, is that the labs, this labs function applies now to each plot in our arrangement, and therefore each plot got a title, which is most of the time not what we want. So this is why we had to use plot annotation. By the same logic, we can write a subtitle, I don't know, just stuff. We could have a caption here. And then what we can also do with plot annotation, if we take a look at, oh, I missed a comma, it's complaining already. If we take a look at the documentation, we see that there is something like tagging possible. So let's try to use this. So tag level, set this to A. So we want to have tags numbered A, B, C, and so on. And then we can add prefixes and suffixes. So tag prefix is this, and tag suffix is the upper parentheses. Now this looks quite nice. We could, I don't know, if we wouldn't have the title and the subtitle here, but we would want to describe this plot in a text, we could refer to this figure or to the subfigures by A, B, and C. Let's try one more thing. Let's try to get rid of this B tag here, because maybe we want to tag only the rows. One thing we can do in patchwork is we can wrap elements together. So we could, instead of having this part here, we could wrap it together, and let's call that wrapped plots, and then put the wrapped plots in here. So using this wrap elements function, we put it together. So what did that do? Well, it did what we wanted to. We have now only two tags, A and B, for the two rows, because, well, now the wrap plots sort of act like a unit, and therefore they get only one tag. But one thing you also notice is that the tag here, or the wrapping, isolated or kind of isolated the two plots from the overall changes. So here you see that the colors and the legend arrangement wasn't applied to it, even though we still have that here. So be aware that you sort of isolate your plots as well from this overall theming option if you wrap it as one element. Another really cool, and this is really the last thing I want to say about patchwork. Another really cool thing with patchwork is that you can put plots into plots really easily. You can do it by insets. And how do we do this? Let's put our box plot, our original plot into into one of the point plots. How do we do it? Well, first let us try to customize a bit so it fits better into the point plot. And I don't know, let's make the background grays. Plot background is element rectangle, and then fill this gray 80. So this is how our plot looks now. So let's call that PLT. And we want to add this to our point plot. So let's take a look at point plot. We want to set it to the top left corner. Maybe make a bit more space on the left so that the plot fits in quite nicely. So let's do that first. We do this by chord Cartesian. So let's map this from 25 to 60. So now we have a bit more space here. And now we can simply insert the element by inset element. Well, what do we want? We want to have the plot. And then we simply need to say with numbers ranging from 0 to 1, where are the edges of the plot supposed to be. So the left edge is at 0.01, so that I like to do it to not set it on 0 but on 0.01, so that the outer line of the panel is still visible and it's not overplotted. So left is that, right, let's say, I don't know, it should end up kind of here. What is that? Maybe it's probably 0.4. At least this is what I did in my blog post, so I will stick to those numbers. Oh, by the way, the blog post, of course, is available via the link in the description. I think I forgot to say this in the beginning of this video, but since I'm sure that everyone is still here who started watching this video, it doesn't matter, I said it now. So here, as I said, we decided how to put in the plot, and as you can see now, our plot was put in quite nicely. And also you probably see why I changed the original box plot by making the background gray and stuff like this, just so that it is visually more appealing. I think it fits better in there. Alright, so I think this is your, let's call it 80-20 tools for working with patchwork. Patchwork can do way more and really complicated stuff. I probably have only used a small bit of all the possibilities with patchwork, but what I've shown you right now is basically what I've already used, and this already got me really far. So I think knowing only these will already get you really far, and this is if you want to do even more, or if something weird is happening with your arrangement, please look at the patchwork site. It has a really good documentation and you will probably find everything you need there. Okay, so this was everything about patchwork. I want to also talk about the ggforce package, because it has a really lot of cool functions which I want to talk about in a different video and a different blog post as well. But it also has one which is helpful for arranging plots. So this is why I will only show you the arranging functions from the ggforce package. So let's create a new plot, and we want to have a grid like if we use facet grid, but we want to have different variables in each subplot. And this can be done with ggforce. All you need to do is to specify the x and y coordinates, not by a specific variable, but by saying, you know what, take the x and y variables or the x and y aesthetics later on from the facet layer, which comes at the end. So this is why I'm not putting in any specific variables in this layer here. I just say use panel y and panel x, and we again want to use colors for sex, and we will use the same point layer as before, so making that a bit transparent, using a bit larger size and making shape equal 21. So shape 21 is basically a point which has both fill and color, and I like to use the shape 21 because then I have the fill, and as you see in this plot before, we have a black curve surrounding the dot. So this is why I like to use the shape 21. So now if we use ggforce, we see that we have something which is called facet matrix, and there you can simply put in all the variables that you want to look at together. So we want to have the flipper length and the bill depth, and what else, the body mass. And there you go. Now we have a grid that puts into uses all of our 4 variables and puts them and arranges the plots like this. So this is maybe not the nicest plot, but it gives you a really good or a really great overview, and is probably useful for exploratory analysis, just looking at a couple of variables simultaneously to find out what's going on in the data. And because this panel X and panel Y stuff here is a bit tedious to write, ggforce comes with an additional layer which is gmautopoint, which has this set up as default, so you do not need to write this, and you get the exact same picture, of course. But here again, this contains a bit, by default, contains a couple of elements which I'm not satisfied with. For instance, here on the diagonal, we have, well, only a diagonal line here. Of course, it's if you put bill length, plot bill length against bill length, then you will get a diagonal. So instead, let us put a density plot there. And by the same logic as before, there's an auto function for density, so this is why I'm using gauto density, and it works pretty similar to the ggplot density functions. I will just make the plots a bit transparent, and I need to make sure that the plots are put together, are put on top of that the positioning is identity, so that the density plots are not put on top of each other, but each starts basically at 0. So if I do this, let's do that, then here we have a weird density plot now in each facet, which is obviously not what we want. We want to have it only on the diagonal and no points on the diagonal. This is this can be done quite easily. Here, let me show you. We simply have to, if we look at facet matrix, there are arguments layer lower, layer diagonal, layer upper, which refer to the diagonal, the upper triangle or the lower triangle. And here we want to have that the diag is set to 2. And then we get what we want. So we see that the 2 is only in the diagonal layer. And how could we understand this? Well, we see that this is the first layer. Just count the layers from 1 to, well, to n, whatever, how many layers you have. And we see that the layer 2 is the auto density, and this is only supposed to go into the onto the diagonals, and this is what we get then here. And by the same logic, we could add another layer. Let's call that gmhex to not use points here. So because here we have the same on the upper triangle as well as the lower triangle. So to get a bit different and a different visual, let's try to use hexagonal counting here. So we use gmhex here. There is no auto function for this, so we are forced to write this dot panel x and dot panel y again. And we want to make it transparent again. So this is the third layer now. So if I want to have the hexagonal counting only on the lower layer, I will need to specify layer lower is equal to 3. And there you go. Now we have the points in the upper triangle, the hexagonal counting in the lower triangle, and we have the density plots on the diagonal. So this is really cool with ggforce. I mean, usually I only use stuff like this for exploratory analysis. So if I want to create a really pretty picture and compose it out of multiple subplots, I will probably still use patchwork. But for exploratory data analysis, it's really cool because it automatically creates a lot of plots for me. And of course, here I do not need to, or here I combined all of my 4 variables with each other. But of course, I don't always want to do it. And we can do that with ggforce as well. We can simply use the facet matrix layer a bit differently here. So let's do a different thing here. Let's look at box plots now. Let me copy this from here. And with box plots, it's a bit annoying that we have to set the grouping variable as well. So we have to set it to some panel, and then we can use facet matrix again. And now we can, for instance, have the columns have something categorical. So for instance, sex and species. And the rows could be something numerical. So the build depth to body mass in gram. You see here that you can also use the tidy selection helpers. For some reason there is a warning message here. I'm not quite sure why this is happening, but still the plot does what I expected to. And yeah, as you can see here, now we have the categoricals here. So on the columns, this is why we had to make sure that the grouping is done according to the columns here. Just make sure that this works together, whatever it is you're doing. And now if we want to add an additional variable to this plot, or want to by using the fill variable, you can do this, of course. So let's do that. So we want to add fill and maybe set this to island. If we do this, then this doesn't quite look like what we want to get. And the point is that we have to take interactions into account, and this is done by using interactions and island. Basically, it combines everything into with each other, so that for each new combined group you will get one visual aesthetic. I'm not quite sure how to describe it best. But in any case, this is now working, and it gives us exactly what we want. All right, that's it for today. I think I've shown you everything I wanted to show you, and I hope that helps you to create cool visualizations. In my opinion, these two packages are really great tools to compose plots, and especially the patchwork syntax, I think, is really intuitive. And once you get started with it, it's kind of fun to see how fast you pick up how to manipulate like the grid width or the grid height and stuff like this. So it's a really great tool to work with. And the same thing applies to ggforce. But with ggforce, there's even more stuff it can do, not only arranging plots. And I will talk about this in my next blog post, and I will see you then. Bye.